This slide talk briefly outlines a new paradigm for the measurement and understanding of public attitudes to climate change. It features the Holy Grail of the long search in the literature for potent, social predictors of international public attitudes to climate change. That is, a single, social variable that can accurately predict the level of such attitudes in any nation, and is also operational across a wide range of different attitudes. As such, it obsoletes the current literature, which finds no potent single predictor, and indeed no particularly strong group of predictors, for which there is also much contradiction about what variables actually form the best predictive groups. Brief comparisons with the literature are made. If using or replicating any material from this slide talk, including the concepts it introduces, please attribute this to Andy A. West, and include my X social media handle, @AndyWest_tweets. The potent single social predictor of international attitudes to climate change, the Holy Grail predictor, is national religiosity. To understand why it works, refer to my book, The Grip of Culture, or to other slide talks. Ultimately, however, it is because attitudes to climate change dominantly reflect cultural identity, and in turn the level of religiosity is an important factor in that identity. Use of this predictor requires a common religiosity scale across nations. I use a very simple scale, self-assessed religiosity, combined with the inverse of self-assessed irreligiosity from a different survey. This produces a scale which is consistent across all faiths and almost all nations. The data comes from mainstream pollsters, such as Pew and Gallup. This predictor works at the national level, across many nations and also across a wide range of different attitudes to climate change. My measurements cover 64 nations so far, and about 40 attitude data series, from about 20 independent sources. Note, due to tribal political polarization, the predictor does not work for the USA. However, the same principles of cultural causation apply, and inform us more deeply about attitudes there. This slide talk focuses upon how the social predictor of national religiosity works across various classes of attitudes to climate change. Why it does so, is left to other slide talks. There are two critical classes of questions about climate change, which produce fundamentally different responses in a systemic manner across nations. These are unconstrained questions and reality-constrained questions. Unconstrained questions are open-ended, and don't introduce constraints in the minds of survey participants. An example, 1, is, how serious do you think climate change is? Reality-constrained questions do introduce a constraint into participants' minds, for instance a priority relative to other issues. An example, 2, is, what do you consider the 3 most serious threats from this list of 10? Climate change is one of the threats on the list. In the following slides, we will look mostly at climate change most endorsing responses to both the above classes of question. For example 1, the climate change most endorsing reply may be, extremely serious. For example 2, it would be picking climate change in the top 3 threats. There are 7 distinct rules that these responses obey, which together cover every possible type of climate change most endorsing response. Although we focus here on how the predictor of national religiosity works, not why, it is worth noting that it is ultimately because public responses are cultural in nature, so emotive, not rational. The first rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to unconstrained questions correlate with national religiosity. The Rule 1 example depicted here uses YouGov data from 2019, across 24 nations. On the y-axis is the percentage level of response, for each nation, of those people answering, a great deal, to the question, how much of an impact, if any, do you believe climate change will have on your life? On the x-axis is national religiosity. From the answer options made available for the posed question, the measured response, a great deal, is the climate change most endorsing response. Note the outstanding R-squared coefficient for the correlation of these responses with national religiosity. At the bottom right of this slide, there is a web link to the YouGov data which the chart here reflects. The second rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to reality-constrained questions anti-correlate with national religiosity. The Rule 2 example depicted here uses OECD data from 2021, across 18 nations. On the y-axis is the percentage level of response, for each nation, of those people agreeing with the statement, cutting emissions by half is not sufficient to stop global warming. This is the climate change most endorsing response, as disagreement implies that climate change, or global warming, is much less of an issue. Cutting emissions represents a reality constraint on all of the things in society that fossil fuels currently enable. On the x-axis is national religiosity. The R-squared coefficient for the anti-correlation of responses with national religiosity is somewhat less than for the last slide, but is still extremely robust for typical values in social psychology. At the bottom right of this slide, there is a web link to the OECD data which the chart here reflects. The third rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to mixed-mode questions, as plotted against national religiosity, occupy an envelope between two linear trends. Mixed-mode questions have both reality-constrained and unconstrained elements. The linear trends are what would occur for each element if it was plotted alone. The Rule 3 example depicted here uses Lloyd's risk data supplied by Gallup, from 2019, across 65 nations. On the y-axis is the percentage level of response, for each nation, of those people saying that climate change is a very serious threat to the people of this country in the next 20 years. This is the climate change most endorsing response. The phrase, in the next 20 years, introduces the constraint. This phrase forces people to set their worries on this score against actual climate trends they see, and also other genuine threats that they might rank higher or lower. In other words, it forces a comparison with reality. On the x-axis is national religiosity. The pattern of responses is not linear, so doesn't have an R-squared correlation value. As well as occupying the envelope between two linear trend lines, the response data may also straddle these lines somewhat, in the normal manner of data about a trend line. At the bottom right of this slide, there is a web link to the Lloyd's risk data which the chart here reflects. Religio-regional groups, that is, groups of nations that are geographically near to each other and also have similar levels of national religiosity, are color-coded and ringed on the chart. This tells us more about how attitudes to climate change vary across the globe, but is not relevant to the overview in this slide talk. With this many nations, I would have expected a couple to occupy the top right of the chart, at least between 80 and 90% on the y-axis. It is maybe just chance that none are there, but there could be some nuance that my theory of cultural causation doesn't address so far. There is a minor variant to the third rule. Some responses to mixed-mode questions, while they still occupy the space between two linear trends that represent what would occur if the reality-constrained and unconstrained elements were plotted alone, nevertheless retain their own linearity. In other words, the data has a significant linear trend of its own. This typically occurs for mixed-mode questions where each of a list of issues requires a graded response that would be unconstrained if the issue was probed alone. Yet assembling them all in a list creates a competitive constraint, and further, the entire list must be visible before any responses have to be given. That is, the issues are not probed one at a time, which would typically produce a nonlinear distribution of responses. The variant example depicted here uses Ipsos data from 2022, across 24 nations. Survey participants are asked, here is a list of some things people worry about these days. To what extent, if at all, have you worried about each one in the last 2 to 3 weeks? On the y-axis is the percentage level of response, for each nation, of those people answering, a great deal, for the issue of climate change, which is one issue on the list. The whole list is visible to participants before they are required to give a response on any issue. The x-axis is % national religiosity. At 0.46, the R-squared correlation coefficient is still quite good for typical values in social psychology, but it is not what is most important for mixed-mode questions. Whatever linear trend mixed-mode responses may or may not retain, their data will always occupy the envelope formed by the trends that would occur for their unconstrained and reality-constrained elements plotted alone. At the bottom right of this slide, there is a web link to the Ipsos data which the chart here reflects. The fourth rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to extremely weakly framed questions, as plotted against national religiosity, occupy an envelope between two very specific linear trends. Extremely weakly framed questions are not emphatic enough to produce any cultural responses. This means modality between reality-constrained and unconstrained responses is lost. National responses simply drift between the weakest trend lines that could still occur for each mode if it was emphatic enough, and also plotted alone. The rule, for example, depicted here uses YouGov data from 2019, across 22 nations. On the y-axis is the percentage level of response, for each nation, of those people saying that they could personally be doing more to tackle climate change. This is the climate change most endorsing response. On the x-axis is national religiosity. The pattern of responses is not linear, so doesn't have an R-squared correlation value. However, responses fill an envelope bounded by the trendlines VWA and VWC. The former is the estimated trend line for the weakest unconstrained response that still retains linearity, and the latter is the estimated trend line for the weakest reality-constrained response that still retains linearity. Responses may straddle the boundaries slightly, in the normal manner of data about a trend line. Spain and Italy are exceptions that escape the envelope. I don't consider my current candidate explanation for these two escapee data points to be robust. I don't know the error margins on the envelope boundaries, but Indonesia and Thailand are probably within the envelope. Although all these responses are not explicitly cultural, I don't think we could consider them to be rational. The drift of data points within the envelope is due to secondary and lesser local factors, but in the end the predictable pattern is still only visible by using a purely cultural x-axis. At the bottom right of this slide, there is a web link to the YouGov data which the chart here reflects. The fifth rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to survey questions as described in Rule 1 and 2, so plotted against national religiosity, may also be lifted on the y-axis, while retaining their expected gradient according to those rules. This is due to non-cultural question components that represent common knowledge, that is, not culturally disputed, although this doesn't always mean it is true. The trendline boundaries of envelopes as described in Rule 3 and 4, may also be lifted in this manner. The Rule 5 example depicted here uses EDF data from 2020, across 27 nations. On the y-axis is the percentage level of response, for each nation, of those people answering yes to the question. On the whole, would you say that, in your region, you have already noticed the effects of climate change? The following Rule 6 leads us to expect a particular gradient for these responses as plotted against national religiosity on the x-axis, and they also obey Rule 1, so correlating. While the gradient matches expectations, the trend line is lifted on the y-axis compared to what we'd expect for a similar unconstrained question having no non-cultural component. The lift is 30 to 40 points. In this case, we know what causes the lift, and in fact this factor requires further resolution, because it is itself a mix of cultural and non-cultural components, illustrating that multiple levels of resolution are sometimes required. See my book, The Grip of Culture, for details. It is not always possible to fully resolve exactly what causes the lift for particular examples. At the bottom right of this slide, there is a web link to the EDF data which the chart here reflects. The sixth rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to unconstrained questions, which as per Rule 1, correlate with national religiosity, also exhibit different trendline gradients according to how emotively aligned to catastrophe narrative each series is. The more the emotive alignment, the steeper the trendline gradient. Catastrophe narrative is the dominant public narrative about climate change, summarized as imminent global climate catastrophe. Because cultures are polarizing, these different gradient trendlines all pivot around a common point. I use 5 series to illustrate Rule 6, each representing the climate change most endorsing responses to different unconstrained questions about attitudes to climate change. Trendlines only are shown. The y-axis is the percentage level, for each nation, of the climate change most endorsing response. On the x-axis is national religiosity. The strongly aligned SA series is the one plotted in full on slide 4. The medium-strong aligned MSA, medium-weak aligned MWA, and 2 weakly aligned WA/WA1 trends are progressively less emotive. Details for these series can be seen on the next slide. For the 5 series charted in the last slide, the tables here show the text of posed questions, the strength of emotive alignment of each question to catastrophe narrative, the text of the measured responses, the number of data points, that is, nations, and the associated correlation parameters with national religiosity. Emotive alignment is stronger where questions invoke the personal, such as say the personal impacts of climate change. The web links to the left of the upper table lead to the original data for each series. The seventh rule is this. In international surveys of attitudes to climate change, the national climate change most endorsing responses to reality-constrained questions, which as per Rule 2, anti-correlate with national religiosity, also exhibit a proportional decline on the y-axis according to how strong the constraint for each series is. The greater the constraint, the more the series sinks down the y-axis. A weak constraint is, say, choosing climate change, CC, as one of the 6 most important issues of 17. A stronger one would be choosing CC as one of the 3 most important from 12. Stronger still would be choosing CC as the single most important issue of 10. I use 3 series to illustrate Rule 7, each representing the climate change most endorsing responses to different reality-constrained questions about attitudes to climate change. Trendlines only are shown. The y-axis is the percentage level, for each nation, of the climate change most endorsing response. On the x-axis is national religiosity. A 4th series, the medium-constrained one, MC, is intuited. I don't happen to have a series that roughly bisects the space between the weakly constrained, WC, and strongly constrained, SC, series. The fully constrained line, FC, is not a real trend line, but an estimate from WC, which is also spot-confined by some real data points for individual nations at the left-hand side. This is possible because reality-constrained series are pseudo-mathematical. I can locate no FC-type series that has the same wording across many nations. Also, responses are so low at the right-hand side that they fall into the general noise level. Details for all these series can be seen on the next slide. For the series charted in the last slide, the tables here show the form of posed questions about the priority of climate change, the measured responses, the number of data points, that is, nations, and the associated correlation parameters with national religiosity. The web links to the left of the upper table lead to the original data for each series. The web link to the UN My World 2015 series is actually an archive link, as the UN removed this survey and results from its websites in 2020. The SC series is composed of 2 surveys combined, which fortunately used the same wording and were conducted close in date. Sometimes, a systemic secondary variance of data about the trendlines shown in the prior charts can be seen. This is typically where the strength of alignment to catastrophe narrative, as per Rule 6, is weak, or the strength of reality constraint, as per Rule 7, is weak. Also, where a greater number of data points is available, this secondary variance can more easily be distinguished from noise. The secondary variance is due to GDP per capita, GDP-PC, but not its absolute value. Rather, the GDP-PC of each nation relative to the average for its religio-regional peer group. Nations near or above the trend line have a high GDP-PC for their group, so, low rank number, while those near or below the trend line have a low GDP-PC for their group. The example secondary variance shown is for the same weakly constrained series, WC, that appears as a trend line only on slide 12. The y-axis is the percent level, for each nation, of responses placing action on climate change within the 6 top priorities out of 17 issues. The x-axis is national religiosity. Religio-regional groups are color-coded, and some GDP per capita boundaries within each group are also drawn on the chart. For unconstrained series, which correlate with national religiosity, this secondary variance is upside down. Nations near or above the trend line have a low GDP/PC for their group, while those near or below the trend line have a high GDP/PC for their group. This chart depicts a summary of all the rules plus secondary features that have been described in the preceding slides. The y-axis is the percentage of the climate change most endorsing response, for each nation, as made in answer to any particular survey question. The x-axis is national religiosity. Trends only are shown. The black trend lines correlating with national religiosity were generated by unconstrained questions, the gray trend lines that anti-correlate with religiosity, from reality-constrained questions. The gray cones represent the envelope for extremely weakly framed responses. The vertical lines between WC and WA1 plus O2, which should stretch to the right-hand side of the chart, except that this makes it too cluttered, represent an example envelope for mixed-mode responses. Mixed-mode questions can in principle produce responses in an envelope between any one of the black correlating, and gray anti-correlating, lines. The series WC1 plus O1 and WA1 plus O2 are lifted series, lifted by offsets O1 and O2 respectively. There can in principle be a lifted series for every one of the basic series, and lifted by any amount that does not require responses over 100%. Envelope boundaries can likewise be lifted. The short, fat, hollow arrows at right angles to the weaker strength series represent the secondary variance of data due to religio-regional GDP per capita. In principle, the climate change most endorsing response to any question in any international, non-US, survey of attitudes to climate change, from 2015 onwards, should be represented by one of the series types in this chart. During the prominence of COVID, from mid-2020 to late 2022, the latest date for any of my results, the same patterns are valid but the average R-squared value for linear series is a bit lower. As well as the climate change most endorsing responses we have focused on, there are climate change less endorsing responses, and even climate change resistive responses. However, it turns out that these don't tell us much more about international public attitudes to climate change than we already know from the most endorsing responses. Hence the model in the last slide, while formally only showing most endorsing responses, represents a full model for cultural causation. Climate change resistive responses to survey questions behave as follows. For unconstrained questions, they are approximately a vertical mirror of most endorsing responses, but typically are somewhat lower on the y-axis at their highest point, at the left-hand side. For reality-constrained questions, typically these can even more closely be predicted from the most endorsing responses, because in an X out of Y priority pick, unless there happens to be a lot of don't know, or no response results, we know exactly how many did not pick climate change within X. Climate change equivocal responses represent those from people who are not culturally committed to, or against, climate catastrophism, as this is represented in the survey questions. For unconstrained questions, equivocal responses typically have low or no trendline gradient with national religiosity. In an X out of Y pick that I use for reality-constrained questions, there is not usually an equivocal option. Participants must pick, or not pick, climate change or the climate change issue being explored by the question. Examples of resistive and equivocal series are shown in my book, The Grip of Culture. The chart on slide 15 that summarizes the 7 rules, forms a straightforward model for predicting attitudes to climate change, from the multi-modal, single, social variable of national religiosity. Here, it is simplified to the diagram on the right-hand side. The left-hand side diagram is typical of what the current literature views as the state-of-the-art for predicting attitudes to climate change, from many other social variables. The circles represent the social variables or drivers, and the lines connecting them are dependencies. Whether direct or indirect, each single driver has low or very low influence, hence also poor predictive power. This is despite enormous extra complexity and the contribution of dozens of variables. In the next slide, we see just how poor the typical predictors from the literature are. The top set of bars in this chart are predictor values from papers spanning over a decade, with off-quoted papers for the older ones, and representing leading-edge models for the newer ones. Some papers include the US, some don't. These papers feature various different predictor types. Their values represent R-squared, pseudo-R-squared, or an approximate equivalent. Predictors may be single social variables, or grouped from simple or complex multivariate models, and may apply at the individual or the national level. Note, Hornsey et al., from which I've taken 6 predictors, H1 to H6, is a meta-study for belief in climate change that spans 56 countries and 171 studies. The bottom set of bars in this chart are R-squared predictor values for the multimodal single predictor of national religiosity, so always at the national level, and for linear scenarios as described in this slide talk. All are pre-COVID in date. The US is excluded. While both the literature and my cultural causation approach produce a range of predictor values, the very best of the former only just overlaps the very worst of those that my linear predictor achieves for some attitudes. The multimodal, single, predictor of national religiosity is outstanding, emphasizing a complete paradigm change in the way we must understand international attitudes to climate change. The table here shows the particulars for most of the data series plotted so far against national religiosity, as depicted and fully explained in my book The Grip of Culture. As well as the 20 series from the above slide, there are some nonlinear series that occupy envelopes according to Rule 3 and Rule 4, plus 13 series which span mid-2020 to late 2022 in date, and hence coincide with the COVID pandemic. The pandemic does not appear to have seriously impacted the patterns we see, as summarized by the chart in slide 15. Some reality-constraint series fall a little, due to competition from an extra threat, and on average R-squared values are down a little. But the general model for responses survives. This slide talk has explained how the social predictor of national religiosity works. For why, see my book, The Grip of Culture. In summary, it is because climate catastrophism is a cultural entity in its own right, a secular religion. And attitudes to climate change across nations are a function of cultural identity, which accepting in the US is owed primarily to levels of commitment to, or rejection of, both climate catastrophism and religion, any faith. This is demonstrated, using the social data we have seen, and more. The book includes a separate chapter for the US, where the same principles apply, but the picture is more complex. Thank you for your interest in this slide talk. Please follow me on X, my handle is @AndyWest_tweets.